Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel. Hi, everyone. My name is Anthony Nathaniel here again, and today in this particular episode of our Crash Mathematics for Senior Secondary School 3 or SS3, in this episode we are going to be dealing with coordinate geometry. And this coordinate geometry is going to be the geometry of straight lines. So basically what coordinate geometry means is, coordinate geometry is basically that part of mathematics that talks about the Cartesian planes and when you plot straight lines or linear graphs. So any straight line on the Cartesian plane is called a linear graph when it is straight from connecting 2 points. But when a graph is quadratic, it is called a parabolic graph. So, but in this episode, we are going to be restricting our devotion and our concentration to linear graphs. And in these linear graphs, there are a lot of items, a lot of things we need to talk about. So, if you already know it, you can just see this video as a brush through. Now, first of all, let's talk about the gradients of a line, the equation of lines, and other terminologies involving lines. First of all, when we talk about Cartesian planes, there are different types of notations used for expressing the equation of a line. So your equation of a line can be expressed in different forms. You can express it as y equals mx plus c, where m is the gradient. You can express it as px plus qy plus r equals 0, where p is the coefficient of the x and q is the coefficient of y and r is the constant in that equation. So in this particular equation, this is another method of expressing the equation of a straight line. So now in this equation of a straight line, you have your expression for the gradient, you have your expression for the intercept, and you have your expression for every other term. Now, first of all, before we delve into the equation of a line, let's talk about the basics, the terminologies. So now, talking about the terminologies, let's deal with the basic form of a line. So what is a line? A line is basically any plate, any connection of points in a plane. So a line is basically a connection of points in a plane. And in this connection of points in a plane, that connection of points in a plane, if it's a straight connection, that gradient, it has a constant gradient. So the gradient will be a constant. But if the connection is not straight, that means the gradient will be represented by a variable, and that variable depends on the location on that plane. For example, if you are talking about an equation of a straight line, you have your gradient given as m. So your y is equal to mx plus c. Now, this equation on gradient is what we're talking about here, and for this equation on gradient, you have different way of explaining them. In this our diagram here, we have our line, and in this our line we have your y and x planes, and then you have your line, and your line is given by y is equal to mx plus c, right? Now this y equals mx plus c, you can see that whenever that line crosses the x-axis, it crosses it at an angle called theta. Now this theta, it is going to be equals to the line. So, and this theta is also a measure of the gradient of the line, because the general equation of a straight line is given by y is equal to mx plus c. And in this case, the m is the gradient of the line and the c is the intercept on the y-axis. And then your other forms of straight line equations, this is not the only way you can express the equation of a straight line. There are other ways of expressing the equation of a straight line. Other forms of expressing the equation of a straight line include px plus qy plus r equals 0. So that is the second way of expressing the equation of a straight line. And then we also have another method. So you will express the gradient of a line as the tangent of the angle that the line makes with the x-axis. So you can see in this diagram again, you can see that angle theta. So the gradient of this line will be given by tan theta. Now that gradient is the tangent of that angle. In other words, it is equal to tan theta. And now that gradient is denoted as m. So this is a good knowledge. So if you are given such an equation like this and you don't know what to use, so you can just quickly substitute. If you are given the angle, you can substitute the angle as m. So you calculate the tangent of that angle, and then if you have the intercept, you can just substitute the value of the intercept, and then just like that, voila, you've gotten the equation of that line. So that is one approach to gradient of a line. So now let's talk about special types of lines. So there are different types of special lines. There are lines that they are parallel to the axis, Now these lines that are parallel to the axis, that's what we're talking about in this particular part. So now we have the line when the line is parallel to the x-axis and when the line is parallel to the y-axis. Now when the line is parallel to the x-axis, for any value of p and q, so where p and q are the intercept of the y and x axis respectively. So you can see in this diagram, this line y equals p is parallel to the y-axis. So when you say a line is parallel to an axis, it is, that means there's no, that means they never meet. Parallel lines never meet. So that means if y equals p, that means you see this line is parallel to the y-axis and it will never meet the y-axis. Now as it's parallel to the y-axis, the equation of that line is equals to y equals p, where p is the intercept on the y-axis. So any line that is, so in this case, when we have an equation like this, y equals p parallel to the y-axis, so y equals p, this equation is actually parallel to the x-axis. So this, when you have an equation of y equals p, is parallel to the x-axis, and then when you have an equation of x equals q, it is parallel to the y-axis. So you can see obviously from this diagram, the y equals p is parallel to the x-axis, and the x equals q is parallel to the y-axis. So that is it. So and then if for any values of p and q, y equals p is the equation of the line parallel to the x-axis, its gradient is 0. So any line that is parallel to the x-axis has a gradient of 0, and rather any line that is parallel to the y-axis has a gradient that is undefined. So it follows that when y equals 0, it is the equation of the x-axis, and x equals 0 is the equation of the y-axis. So these are basically talking about the lines and the axis, when you have a line parallel to the axis, and so on and so forth. Now let's move on to the next section of this video. So and then this next session we're talking about when you are sketching your straight line. So how do you sketch your straight lines? When you are sketching your straight lines, you make use of the intercepts. Now in these diagrams, I'll talking about the gradients. So how to make use of the line, how to express them, and then sketch them when you are given the equation. So if you are given the equation, all you need to do is you sketch the lines in the following way. Now you can see in the above lines that you have here, you have the first line, the figure A. You have your line as you have your intercept on the y-axis as c, and you have your intercept on the x-axis as minus c over m. So you can see that. Now this particular figure A, it is basically the equation of the line y equals mx plus c. So that is how it is. So that's the equation of the general line. So when you have any equation of y equals mx plus c, automatically the intercept on the y-axis is c, and the intercept on the x-axis is minus c over m. So secondly, when you have any equation in the form of px plus qy plus r equals 0, automatically your your y-intercept will be minus r over q, and your x-intercept will be minus r over p. So you can see that's the diagram there. So these are basically shortcuts you can use to find the intercept and to sketch a curve. So if you are given your equation, you can sketch the curve using this intercept, and then if you have your curve, if you have your line, you can derive the equation, vice versa. So it's kind of like a two-way relationship between your equation and your graph. Now I hope you've been able to understand that concept. Now let's move on to the next part of this video, where we'll be talking about your distance between 2 points. Let's talk about the distance between 2 points. Now the distance between 2 points is given as the square root of x2 minus x1 square plus y2 minus y1 square, where x1 comma y1 is the first point P, and then x2 comma y2 is the second point Q. Now in this case, we are talking about the distance between two lines. So when we are given the coordinates of those 2 points, so the distance between 2 points x1 comma y1 and point x2 comma y2 is given by this. So this is the equation of distance between 2 points. So it's given as the square root of the difference between the x coordinates of the lines plus the square of the x coordinates of the lines and the square of the y coordinates of the line. So when you add them together and you look for the square root, you get the distance between those two lines. So that is the general equation for that. We'll also be solving questions on this, so just follow me through to the end of this video. Now let's move on to the next part of this video, where we're talking about the midpoint of a line. So how do you look for the midpoint of a line? Now when you're looking for the midpoint of a line with this same coordinate x1 comma y1 and coordinate x2 comma y2, it's basically expressed as the midpoint. So you have that the midpoint of those two lines is given as m equals x1 plus x2 over 2. That is the average of the x coordinate, and comma the y1 plus y2 over 2. So when you have 2 points, the coordinate of the midpoint is basically the average of the x coordinate of the 2 points and the average of the x coordinate, and the average of the y coordinate of the 2 points. So that's the x comma y. That will be the new x and new y. That's the coordinates of the midpoint. So this is the expression. You can write it down if you don't know it before, and if you know it, you can also chill with that. Now let's move on to the last part of this video. Now that will be when we're talking about the angle between two lines. Now when we're talking about two lines, we have to talk about the angle between the line and the x-axis. So basically, the angle between two lines is basically the difference between the angles in the x-axis and the angles of the first line, and the angle between the line and the x-axis of the second line. So basically, that is the m. Now there is an expression for calculating the distance between two lines in mathematics, and you can use that we'll also give you that in this video. So basically, that the angle between two lines, rather not the distance, the angle between two lines there's an expression for it. But if you want to look for it graphically, all you need to do is you need to sketch the two lines. So you sketch the two lines and then you project it, and then the angle between the lines, you calculate the angle. So basically, when you sketch the two lines, you calculate the angle between the lines. So that's the graphical method. But if you cannot draw the two lines, there's a formula for that, and the formula is given by the angle between two lines, the tangent of the angle between two lines, tan equals m2 minus m1 over 1 minus 2, over 1 minus m1 m2. So that is basically 1 plus m1 m2. Now basically, if you are looking for the angle between two lines, the tangent of the angle between two lines is given as the difference between their gradients divided by 1 added to the sum to the product of their gradients. So this is the expression where this m1 and m2 are the gradient of the two lines respectively. So when you are able to calculate the gradient of a line, you'll be able to know the angle between those two lines without drawing any curves. That is very wonderful, and that is one of the joy of mathematics, the ability to be able to sketch and to be able to skip sketching and to skip the graphical method by the application of formulas. Now hopefully you've been able to come to the end of this video, and in our next section of this video, let's talk about the calculations. So let's deal with calculations. I'll be giving two different calculations, and the first one is I'll give a calculation on distance between two lines and calculation on the midpoint of two lines. So let's talk about the distance between two lines. So when we have a distance when we have in this example theory, let me give an example theory. We have to find the distance between each pair of points. So we have number A as 7,2 and 1,6. So you are looking for the distance between these two pair of points. And then this number A, how we solve it, you use the formula using L, which L is the length of the line. So that L is the distance between the two lines. L is equal to the square root of, open brackets, x2 minus x1 close bracket squared. That means the square of the difference between the x coordinates of the 2 points. Then you add to that the square of the difference between the y coordinates of the 2 points. Or in other words, that's open brackets y2 minus y1 squared. That means for your A, you have that will be L will be equal to the square root of 7 minus 1 squared plus 2 minus 6 squared, and then that will be 7 minus 1 is 6, that's 6 squared, plus 2 minus 6 is minus 4, that's minus 4 squared. That will be root 52, and at the end of the day you get your distance as 2 root 13. Now you can also solve that. You can also evaluate the value of root 13 by using your logarithm table or your calculator, and then that will give you a value of 3.61. When you plug that into your equation, you will get 7.22 units. So that is the distance between the 2 points, 7,2 and 1,6. Now in the number 2, which is number B, it is still the same method. You basically use the same formula, plug your coordinates of the 2 points, your x and y coordinates, and then you evaluate using the formula. Then you, at the end of the day, you have our answer as 9.43 units. That is the distance between the 2 points on the Cartesian plane. So I hope you understood that example. Let's move on to the next part of this video. Here we're talking about the coordinates of the midpoints of two lines. So the coordinates of the midpoint of two lines, we have so we have find the coordinates of M, the midpoint of the line joining P, which is which is the which has the coordinates 1 minus 1 comma 4, and q, which has the coordinates 5 comma minus 2. Now using x comma y, we have the equation as the x comma y coordinates of the midpoint is given as open bracket x1 plus x2 over 2. That is the average of the x coordinates of the original of the original point, comma y1 plus y2 over 2, which is the average of the y coordinates of the original point. Now when you evaluate that, you have the x coordinate of the midpoint is given as x1 plus x2 over 2. That is minus 1 plus 5 over 2. That will give you 2. Then your y coordinate is given by y1 plus y2 over 2. That's 4 plus minus 2 over 2. That's 1. So when you evaluate that, you have your midpoint as point 2 comma 1. So that is the end of that question. Now I hope you understood this video sufficiently, because this is the this is basically all we have to do in coordinates geometry of lines. So hopefully I'll see you in the next episode. Thank you for watching.